The last thing I want to touch on is the idea of test cross. So we can also use genetic diagram and Punnett square to work backward to determine what is the genotype of an organism that shows the dominant trait by crossing it with a homozygous recessive organism. What do I mean by that? We know that for tall plants, there are two possible genotypes. One is homozygous dominant, big T, and one is heterozygous. Both will look tall from the outside appearance. So how do we know which is the genotype that the organism have? Alright, so test cross, okay, is used to determine based on the outcome. We know that different combination gives rise to different ratio at the end. So using a test cross, we can also work backward to determine. So say if the plant is a homozygous dominant in case study 1, what would be the phenotype of the offspring? So we can use the Punnett square over here just to quickly solve this question. Alright, same thing. We put the phenotype of the parents as well as the genotype of the parents at the side of the Punnett square, right? Before we proceed on to determining what the ratio would be. So if, okay, if organism is homozygous dominant, the ratio of the phenotype of offsprings is, okay, all tall hybrid. Okay, so if all the offsprings are tall in nature, after crossing them together, you will still get all tall offspring. Alright, and likewise, if the plant genotype is heterozygous, one big T, one small t, alright, this is what we will get. Okay, alright, so you can see the different combination over here, big T, small t, small t, small t, big T, small t, small t, small t. So what would be the ratio? It would be 1 heterozygous to 1 homozygous recessive. So ultimately, the phenotypic ratio is 1 tall is to 1 dwarf. So based on the ratio that we have obtained, we can also determine, alright, the unknown genotype of the organism. So always end off with a statement, a word statement to conclude your answer. So if organism is heterozygous, the phenotypic ratio of offspring will be 1 tall is to 1 dwarf. Okay, so in reality, if we breed a heterozygous as well as a homozygous recessive, we'll get 1 is to 1, all right? 50% tall plants, 50% dwarf plants, all right? So in this given example over here, you are given a black guinea pig and a white homozygous recessive. So always start off with a legend as well. We know that, okay, B represents dominant allele for black, and then small b represents, okay, recessive allele for white. This is a good example to show, right, that the question did not specify whether or not to draw a genetic diagram or a Punnett square. So always go with Punnett square if the question didn't ask to save some time in answering the question. So there are two case scenarios over here. A black guinea pig has two possible genotypes. One is a homozygous dominant genotype or heterozygous, whereas for a white guinea pig, definitely is small b and small b. So we have two case study over here and we'll have to illustrate. Okay, so first, if black guinea pig is homozygous dominant, okay, This is what we'll get in our Punnett square. Alright, so same thing. Okay, big B. Alright, for black. Okay, always cross it with a homozygous recessive. So this time round, it's a white guinea pig, small b, small b. Alright, so you'll get your answer immediately. All the offspring, okay, would be black in color. Alright, so you end off with your statement. If black guinea pig is homozygous dominant, all the offsprings will be black hybrids. Right? Okay, the next case scenario is black guinea pig is heterozygous. Same thing, illustrate with a Punnett square. Right? Big B, small b, and then cross it with a homozygous recessive white pig. Okay, and this is what you get. Right? So if black guinea pig is, sorry for that, is, alright, the phenotypic ratio of offspring, okay, will be 1 black is to 1 white. Alright, so this is how we determine whether the genotype of a dominant trait using a test cross over here. So I hope this is clear.